So, in the last session, we started data structures and algorithms with the Python a new batch. So, what the topics we are going to discuss as a part of this course? There are two segments will be there. In first part, what are all the various algorithms are there, and what are all the data structures are there? Both as a separate part we are going to discuss, and even we are going to see what are the different sorting algorithms I explained. Like there are predefined methods are there, and also user defined methods are there. If you take predefined method, suppose if you take any sorting, we have two types of methods we have. One is list.sort, another one is sorted function. When we have to use list.sort, and when we have to use this sorted, I demonstrated in the last class. Even we covered multiple examples also related to that. Okay, multiple examples I demonstrated. Okay, so next, what are the examples we covered? Like how to sort integer objects, how to sort the integer objects in descending order. So next and after that, how to sort string objects, how to sort the objects, string objects based on their length. So how to sort the string objects based on the last character. Okay, next and after that, how to sort student objects based on the different parameters. So these are the things that we discussed in our last session. Okay, so now we are going to talk about user-defined sorting algorithms. What are the various user-defined sorting algorithms we have? Sir, but before moving to that, we have to talk about two important properties in sorting algorithms. What is the first property is the next thing related to sorting stability. Stability in sorting algorithms. Sir, what is mean by stability in sorting algorithm? Sir, generally we are going to sort the data, right? Whenever you are sorting, if the data contains duplicate elements, assume I want to sort 30, so then 20. Okay, so 30, next 10, next 20, next 10, next 40. Like that, I have an input. So whenever you are sorting, what is the output you will get? 10, comma 10, comma 20, comma 30. So like that, we are going to get. Now my question is, here there are two 10 values are there, means duplicate. If any duplicate is coming, is that a duplicate will be available in the same order or they are going to shuffle? So meaning is, if any duplicate objects are there, is the comparison is going to be done or not, we have to check. That is called as what? Stability in sorting. Stability in sorting. Okay. So in sorting algorithms, so if the input order and output order of uh, duplicate of duplicate elements, so is the same, then such a type of sorting algorithm maintains stability. Sir, unnecessary comparisons are not required. That is nothing but the main concept of stability in the algorithms. Okay, sir, don't worry. If we are clear with the theory part, then in detail I will demonstrate. Any questions up to this? Clear? Right. So in short form, if I want to demonstrate, sir, if two elements have the same key or value, so their order, okay, their original order is preserved. Their original order is preserved after sorting also. That is nothing but stability. I will give some examples also so that you can understand well. Let me take test.py. Observe carefully. I am taking some list with some items like 2 comma triple A I am taking. Okay. Next 1 comma triple B I am taking. Next 3 comma triple C I am taking. Then so 2 comma uh, triple D I am taking. Now I'm going to print this list. Then I will do L dot sort. Sir, what will happen? I want to show you in programmatic. Let us see. Py space test dot py. Are you seeing, sir, 2 1 3 2 before sorting? After sorting, sir, 1, then 2, and then 2. Sir, is this 2 is coming first or this 2 is coming first? This 2 is coming first. You may feel that, sir, since triple A is there, that's why it is coming first. No. If you take triple Z also, so that will come first. Okay, sir, is it changing? Yes, it is changing. So that means this list dot sort method is not following that order, right? So it is comparing based on which items. It is comparing big based on the equal items also. When two elements are same, then it is comparing like that. Don't worry. So this algorithm is not providing support for sorting, stable sorting. Later we will see how it is going to work. So do you have any questions? Are you clear with the stability? Please confirm.
Sir, in short, if two duplicate elements are there in input and the
Hmm.
order is same in the output also, they
Hmm.
follow the preserve the order, then it
Hmm.
is
Stable algorithm.
stable algorithm. Okay.
Hmm. Clear?
But for now, this sorting algorithm is not a stable
Is
algorithm.
not stable. Is
Okay.
not stable.
Okay.
Clear? Now. So one more property is there. What is the another property is in place. In place sorting algorithm. So when we can say a sorting algorithm is said to be in place is, so if an algorithm is not using any extra space while sorting, then such type of sorting algorithms are called as in place sorting algorithms. Okay, in place sorting algorithms, remember carefully. So there are only few algorithms which are in place, sorry, not in place. If you take bubble sort, so selection sort, merge sort, not merge sort, quick sort. So these sorting algorithms, they are going to use extra space. They are not going to use extra space. So if they are using list, with the list only they are going to do the sorting. If anywhere order is changing, they will update in the same list. They won't come out. Okay. But if you take merge sort, okay, if you take merge sort, we are using some extra space. So it is called as what? Not in place, not in place sorting. Sir, what is mean by in place sorting? If your algorithm is not using any extra space, means it is called as in place sorting algorithm. If it is using any extra space, then it is not a in place sorting algorithm. Like that we have. So if you are clear with, then one by one predefined sorting methods we covered, right? Like that I will take examples for user defined sorting algorithms also. Clear up to this? Right. So now the main thing here is the first sorting algorithm which we are going to take here is bubble sort. Bubble sort algorithm. Sir, what is mean by bubble sort algorithm? Sir, first step, it is used to it is used to sort the data in ascending or descending order. It is used to sort the data in ascending or descending order. It is a stable sort. Sir, stable sort means what? I told already. If duplicate elements are there, that relative order will be maintained as it is. Next, sir, first element will be compared. First element will be compared with second element. So if, sir, first element is greater than second element, then swap, else no swap. Like that we have to compare adjacent elements. Don't worry, I will show you the proof first, then we will go for programming part. Okay, suppose consider I have a list is there here with elements, so 10. Let me write directly. So I have a 10, so then I have 40 is there, so next 30 is there. Okay, so next 60 is there, next 20 is there, and assume 50 also. Like that we have. Sir, in first step, what we are going to do is we will compare first element with second element, 50 with 10. Is 50 is greater than 10? Yes. Then swap, interchange the values. Now compare 50 with 40. Sir, 50 is greater, right? So interchange those two values. Now compare these two. Is 50 is greater? Yes, sir. Interchange these two values. Now is 50 is greater than 60? No. So no swapping. Compare 60 with the 20. Is 60 is greater than 20? Yes. Then swap, here 20 will come, here 60. Sir, you can see these elements get sorted. Last element. So the first largest element will be moved to the ending. Clear, friends, up to this? Clear, friends, up to this? One second, please. Right. So, shall we go for a program? Shall we go for a program? Right. Now have a look once. I'm going to take a list here. Okay, I'm going to take a list here. List L is equal to, okay, list L is equal to, sir, one empty list I will take. And for I in the range of 10, that means 10 times it is going to work. L dot append of random dot rand int of 10 comma 99. Sir, what is the meaning of this? You know about random module, right? In the random module, there is one special function is there with name rand int. There is one special function is there with name rand int. What that rand int function is going to do? It will generate one random integer value in between these two. Sir, in between these two values, it will generate one random value and I am appending that random value to the list. Now, if you are trying to print the value of list, so you will get random values. Let me check by running multiple times. So random is not defined. Sir, if you want to work with a random module, what you need to do? We have to import random module, right? Now have a look once. Every time you can see we are getting 10 different numbers. Now my question, I will create a function called bubble sort. So just I am going to pass the list. Now print here. So what this bubble sort is going to do? Sir, it will sort the data. Okay. Now have a look once. Sir, bubble sort. Bubble sort, I am going to take a list. Sir, for each I value in the range of length of the list minus 1 and for each j value in the range of length of the list minus I minus 1. So what I am going to do is I will compare the adjacent elements. Is L of j is greater than L of j plus 1? If yes, we are going to change L of j comma L of j plus 1 is equal to, so L of j plus 1 comma L of j, like that we have. So I will show you how it is going to work with indexes and with terminology. So consider my elements are, we have 40 is there. So next 10, okay, next 50 is there. So next 20, next 30. Like that, I have some list of elements. What about their indexes? It is a 0th location, first location, second location, third location, fourth location. Like that we have. These are nothing but the locations. Now observe carefully. Sir, first time, what is the value of I? I value is initially 0. Now, what possibilities of j you will get? Sir, length of the list. How many elements are there here? 5. Sir, 5 minus I value is 0 minus 1. That means 4. So, range of 4 means what? You will get 0, 1, 2, 3. Sir, when j is equal to 0, we are comparing L of 0, that is 40. Is it greater than L of 0 plus 1, 10? Yes, that means we are swapping these two elements. So j is equal to 0 completed. Now j is equal to 1. First location element will be compared with j plus 1. That means next location element. Is the condition is true? No. So that means swapping is not required. Next, so take the second location element and compare with second location plus one third location element. Is the condition is true? Yes. Now what will happen? Swapping is going to be performed. Here 20 will come and here 50 will go. So next what will happen? Sir, we are taking 50 and comparing with 30. The condition is true, right? So here 30 will come and here 50 will go. So this is nothing but I is equal to 0 execution. Clear everyone? Clear? Sir, please respond. Unmute yourself and please respond clear.
Sir, first loop is for iteration of number of elements, and second loop is for the element comparison and swapping.
Yes, yes.
In that way. Okay, okay.
Now, if you take I is equal to 1, what will be your j values? Sir, I value is 1 means length of the list is 5. So 5 minus I value is 1. Already 1 is there. 5 minus 2. That means 3. Sir, 3 means which values you will get? 0, comma 1, comma 2. Now see, sir, 0th location, that is a 10, will be compared with 40. Sir, condition is not satisfied. Now take the next element, which is nothing but 40, compare with the 20. So condition satisfied. So here 20 will come and here 40 will go. So next 40 will be compared with the 30. So condition is true. So here 30 will go and here 40 will come. So next only 3 iterations, right, completed. Can I say in the previous case the largest element is moved to the end. Now the second largest element is moved to the end. Clear, friends, up to this?
Yes.
Any queries here?
Can you explain the random function, rand int, what it is doing?
Rand int is going to generate one random integer value. It will generate one random integer value in between these two parameters. So this is inclusive. So this is also inclusive. Okay.
And how
So
many integers it is going to generate?
only one integer, madam.
Okay, so we are running it for 10 times, so it will generate 10 at random.
Yes. Every
Okay.
random will be stored in a list. So why I
Okay.
am using this concept? Because if I generate random numbers, before and after swapping, what is happening, we can able to see very clearly, right?
Right, right. Got it.
Right. Any questions? Right. Yeah. So just a second. Just a second.
And, like time complexity and space complexity that we are going to cover now.
That we will discuss later, madam.
Sir, one question in this, when you do for I in range, length of L -1, why are you exactly doing -1 there? Because range always anyways exclude one digit, right? While looping. Can you
Yes.
explain this part? Yeah.
Yeah, sure, sure, sure. So now you can see here. Maybe if I go in detail, you may get clarity. Let me take I is equal to 2. Okay. So j values will become what? 2 means, sir, 5 minus 2 minus 1. That means 5 minus 3, 2. If you take 2, what will happen? You will get 0, comma 1. Now observe. So first element will be compared with the second element. Condition is false. So second element will be compared with the third element. The condition is false. Now we are taking I is equal to 3. So for that j value will become what? Sir, 5 minus 3 minus 1. That means 5 minus 4 only. Sir, j is equal to 0. Now 0th location element will be compared with the next element. Already this is sorted. Sir, now condition is false. That means this element gets sorted. Is it required to take I is equal to 4? No, right? Because there is only one element is there. So, which is already sorted. That's why what possible I values we are expecting? 0. So, 1, 2 and then 3. So, if you take a range of 5, now what will happen? It will generate 0, 1, 2, 3 and also 4. That's why if I take a range of 4, 0, 1, 2, 3 alone it will generate. Now you got the clarity, sir?
Yes, sir. Yeah. I think it will be index out of range if we take the exact length because indexing
Yes,
starts from 0, right?
yes, yes,
Yeah,
yes.
got it. Yeah. Thank you, sir.
Right. And in
So,
J loop also again why we are reducing minus I? Because every time one element get sorted, right? So next time only these three elements will participate in the game. These two elements we have to remove. Got it? Clear? Shall we go for execution?
sir, one quick question here. The rationale behind that we are going through all these algorithms is like our need is to sort data in our like
Hmm.
project. So we'll take any
Yes.
of these approaches, right? There is no other approach apart from this.
Any approach you can say. See, ma'am,
Yeah.
what I observed is you are thinking about always application oriented. Sometimes we need to see what is happening. So there are so many sorting algorithms are there. By observing all these algorithms, some algorithms are suitable for some applications, not for all. That we need to identify. Understood, madam?
Yeah, understood.
Now, so let us execute this and check really is a sorting is a performing or not. Sir, you can see these are the elements before sorting and these are the elements after sorting. You can see all the data got arranged accordingly in sorting order. So this is ascending order. This is ascending order. If I want to do descending order, what is the modification that we have to do? In the place of greater than, take less than. Automatically what will happen? Descending order you will get. So if you want to sort the data in descending order, just only one change is what? That symbol if you change, automatically descending order will come. Sir, if we are clear, then there is one more approach is there. I mean, in bubble sort, there is one small loophole is there that I will address. Are you clear up to this?
Yes, clear.
Right. So, what is the next approach that we have here is, so what is the next approach is, assume I'm not taking this. Okay, I'm not taking this. So consider I have a list with elements 10, 20, 30, 40, 50, 60, 70, 80, 90 and then 100. 10 elements only. But unfortunately, all these elements are already in sorting, right? So let us count how many times this sorting algorithm is going to work. I want to count how many times it is going to work. Sir, how you can decide? Let us take initial count value as a 0. Now, whenever I am entering into this I, so I will do count is equal to count plus 1. Okay. So now I want to print the total number of, so total number of iterations. How many iterations it is doing? I want to count. So I think better if you declare that one as so global C, then it will be good. Now observe, sir, even though, sorry, second, here it is greater than, right? Ascending. Sir, even though the list is already sorted, unnecessary 9 more comparisons we are going to do unnecessarily, right? That we can change in bubble sort. Are you clear? Clear up to this? How to remove that, I will explain.
Internally, one second. So, like the iteration at the I level, but at J level also again the iteration will happen, right? So that
Yes,
steps will
ma'am.
also be count, right?
What I am telling is, you can see, whenever we are entering into the I iteration, I am going to consider it is the first pass. Okay. I is the main element, right? Then internal comparison is secondary. What I am telling is, if you are doing bubble sort, if already list is sorted, again 9 times the comparisons is going to be done. That practical proof I have shown you. Is it clear?
Yes.
Now, observe my logic. What is my logic is, first element compared with the second element, no swap. Second element with third element, no swap. 3 with 4, no swap. Like that, if we are comparing every element in J iteration, there is no swapping. So when I is equal to 0 itself, if there is no swap and happen, that means the list is already in sorting, right? Is it required to take I is equal to 1? No, we can stop. Are you understanding the point?
Okay.
Can I stop that? So how I am going to do? Here, I am taking a special variable like flag is equal to something like false. Now, here I am going to verify flag is equal to true. What is the meaning of this? If at least one swap we are going to do, then I will make it as a true. Now, sir, after completion of the comparisons, before moving to the next I iteration, I will check. If a flag is equal to false, what is the meaning? All the elements are already sorted, right? Simply break the loop so that the next iteration won't be there. Now observe, same program I am running. How many iterations? Only one. If the list is already in sorting, within first iteration we can conclude that. No need for the next comparisons. This is nothing but what we can say improved version of a bubble sort. So if the list is already in sorting order, then only we can apply this. If the last list is not in sorting order, no need to apply. Okay. So this is called as what? Improved version of bubble sort, and it is applicable if the list is already in sorting order. Otherwise, no need to apply this. Are you clear, everyone?
Sir, how did you break that? Could you please explain that?
Here, initially, at the starting of the algorithm, I am declaring that list is
False.
already sorted. I am assuming that. Okay.
Okay.
Now, sir, I value I am starting. This is I loop. This is I loop. This is outer loop only. Now, if this condition is satisfied, what is the meaning of that? First element is greater than its next element. That means I am doing swapping, right? Correct?
Yes. Yes.
If a swapping is done at least once, then I am changing the flag value as a true. Okay. Now, outside of this J loop, I am checking one condition. If a flag is equal to false, then I compared all the elements, but there is no swapping happened. What is the meaning of that? The list is already in sorting, then only swapping is not going to be happen. Now, is it required to run for I is equal to 2? No. We are inside I loop, right? So, whenever the value of a flag is equal to false, I am going to terminate, no need to continue, like that. Got it?
Sir, we are doing breaking this on the basis of first two element. If they
Ah,
are
yes.
shorted, then we are breaking it. We are not
Yes.
checking the remaining elements.
Yes.
Sir, what will happen if the remaining element is not in a shorted order?
This flag variable will set to true, right?
No, actually,
No, it
we
will
are
come
getting.
out of loop
One by
in the
one, one by
first.
one, one by one. Sir, see, here the list assume 10, 20, so 30, 40 is there, right? What is the initial value of a flag? I am taking false. Clear? What is the starting value of I? Start from 0. What is J value? Starting from 0, you will get 1, you will get 2. Correct, sir?
Yes, sir.
We are comparing 0th location element with second location element. Is the condition is true? No.
No.
Second element we will compare with next element. Is the condition is true?
No, sir.
Is the third element is compared with fourth element? Is the condition is true?
No, sir.
So what is the meaning of that? List is already in sorting order. Correct?
But sir, still the loop we are going inside the nested loop, right? We are we are going inside that nested loop.
Sir, that's what I am telling. Sir, for I is equal to 0, we are executing this.
Mhm.
So when I is equal to 0, we started this. We traversed all these. But this flag value is false, right? Now, is it required to go for I is equal to 1? No. Why? Because this at least one condition is not satisfied means there is a change in the order. If already these are in this order, always first element is less than second element only, but not greater. Are you understanding, sir?
Got it, sir. Got it. So in
Hmm.
first loop, we are checking with all the other elements. If it is shorted, then we are
Hmm.
marking it as a shorted.
Yes. So here I am checking. If at least one time swapping happened, your flag value will become true. But at least one time is not happened, right? Then I am going to skip. Sir, you are thinking with a small amount of data. Assume your size of the list is 100. Then with I is equal to 0, we can take a decision that remaining 99 iterations are required or not. Understood? Not only that, suppose if you have 10 elements are there, sir, after 1 comma 2 comma 3 iterations, if the list get sorted, no need to further write. Clear everyone, please confirm so that we will go for the next sorting. Clear on?
Sir, one quick question. I think one is insertion sort where we compare only the first element with all the remaining elements, right? I don't recall the exact service sort method. I think that's
Can
where
you
we
come
are.
again? Can you come again?
I think there is one more method. I think maybe it's called insertion sort, where we compare only the first element with all the remaining elements.
That is a selection
Uh,
sort.
Selection sort. Yeah, I think we are getting confused there. We are like
See,
confusing between bubble and selection.
bubble sort means bubbling. Bubbling means what? One after another, right?
Yeah,
We
that's where
will,
like even that the
yeah,
same question I
we are
asked earlier. But
comparing. Oh, no, no. First element
yeah,
will
yeah,
be
I got
compared with
now.
the
I
second.
got it now.
Yeah.
Yeah.
Sir, if at the last, like in first loop, if
Hmm.
90 is before 80, that flag will become false and it will
Hmm.
go for second I.
Hmm. Yes, yes.
Okay.
What you can do, even you can take this flag here also, right?
Yeah.
And we can terminate.
Yeah.
If the
Okay.
list is partially sorted, then you can do that.
Okay. Okay.
Clear?
Yeah, in that case, let's say if like in list of 10, if first 5 or only need to be sorted, rest 5 we need not run iterations for.
Yes, exactly.
Yeah.
And what is the problem with the bubble sort is, you can see you will get more swappings. Am I right? Because this one is there for adjacent elements comparison, right? If anywhere first element is greater, suppose consider I have some 40, okay, next 10, so next 20, next 30 is there. We have a clear clarity that 40 we need to move to the end, but we are not moving directly. We are moving indirectly. First we will swap these two, then we will swap these two, then we will swap these two. More swapping rights are required. Instead of that, directly can I move? Yes, that is called as selection sort. In selection sort, we will select one element and we will move. But in the case of a bubble sort, what we are doing? Sir, we are bubbling every time. Got it? Is the input for selection sort is clear?
Yeah, got it.
So now let us go for selection sort. So what is mean by selection sort here? Here also the same kind of scenario. Sir, selection sort, we are going to select an element and and fix that element in its position. Sir, what about that position? If it is descending order, you need to move the smallest element to the last. If it is ascending order, you need to move the largest element. So, first minimum element or first maximum element. Okay, so first minimum element or first maximum element will move to the last location. Then, sir, second minimum or second maximum element will move to the so last before location. Like that we have to do. Like that we have to do. Sir, is it stable algorithm? Is it a stable algorithm? Can anyone tell me is it stable algorithm? It is not stable. Sir, is it in place? Yes, it is a in place sorting. We are not required to use any extra memory. So let me give one example, then you can understand well. So what is the example here I'm taking is same, assume 40 is there, so 10 is there, okay, 50 is there, so next 20 is there, next 30 is there. What about their locations? 0th location, first location, second location, third location, and fourth location. Okay, observe carefully. Sir, I am going to consider the minimum element index. So the minimum element index is 0th location. In the 0th location, I have a minimum element. Like that, I will assume. Now, I am checking, is 10 is less than 40? Yes. That means 40 is the biggest. Now, I will take 50. Is 50 is less than 40? Sir, condition true or false?
False.
False.
So condition is false. Condition is false means what? 50 is greater. The element which is present at a second location is the maximum. Clear?
Right. For now, yeah.
So now what is the next element? Sir, 20. Is it less than 50? I think better you can use greater than symbol. Is it greater than 50? Condition is false.
So 50 remains again 50 for next comparison.
So now what will happen? What is the next element? 30. Is
30.
30 is greater than 50? No. Sir, what is the meaning of that? All iterations completed. The element which is present at the second location is nothing but which element? Maximum element. Sir, now you have to swap only this element to the ending, and whatever element is there at the ending, you need to bring here. Like that, we need to write the code. So now the last element get sorted. Clear, friends?
Clear, clear.
How many swaps? Can I say only one swap?
Mm,
Every
yeah.
time we are not swapping, right?
Yes.
Clear? Any questions? Yeah.
So one use case for this can be like if we have to select the maximum element from the list, this method can help, right? To select the maximum.
Yes. We have to run a iteration
Yeah.
to get the elements one by one.
Yeah.
Right. So second time what will happen? So I am assuming the maximum index is 0. Now take the next element. That is nothing but what? Sir, what is the next element? 10. Is 10 is greater than 40? Condition is false. Is 30 is greater than 40? Condition is false. Is 20 is greater than 40? Condition is false. Sir, what is the meaning of this? The element which is there at 0th location is the minimum. Now swap with the last before. So this element also gets sorted. Next, we will assume the maximum index location is 0. Compare 10 with 20. Condition not satisfied. Compare 30 with 20. So condition satisfied. The element which is available at second location is the minimum. Swap second location with second location only. Like that it will perform. Are you clear with the logical part? Then I will go with coding. Clear?
Sir, I'm not getting that maximum
Maximum index.
index, huh?
So initially we will take the element which is available at 0th location is the maximum index.
Okay, we'll assume that directly.
We will assume directly. Now, other than that, remaining all the elements will be compared with that element. So in the remaining comparisons, if any element is there greater than that minimum index element, that will become, I mean, maximum index, that will become maximum index element, right? Clear? Can I go for
Clear,
coding?
clear, clear.
Can I go for coding? Please confirm.
Yes.
Now have a look once. Now let us go for selection sort. So let us see how I am going to write the code. First, I will find length of the list for my convenient purpose. So now, for each I value in the range of n minus 1, I will consider the maximum element index is 0 for each j value in the range of that element you are not required to take, right? So I plus 1 to remaining all the elements. If any element is greater than the element available at max index, then what is the meaning? max index will become what? That is J. That's all. After this, swap L of J with not L of J, L of I with L of maximum index location is equal to L of maximum index comma L of I. Sir, which element we have to take? Not L of I, because we need to move to the ending, right? So how to find out ending? L of n minus 1. Here also L of n minus 1. Okay. So now, first time when I is equal to 0, what is the last location? Sir, fourth location. How I can write 4? Can I take 5 minus 0 minus 1? When I is equal to 1, sir, last location is 5 minus 1 minus 1. That is 3. So what is the formula? N minus I minus 1. Even in our previous example also we covered this. Okay. So now let me check, is it working or not? What is the name of the sort? Selection. Now have a look once. Sir, is the data is coming? No, because you can see 1975, it is not moving. So what mistake is there? Anyone, can you please tell me? Here not 0, right? We have to take I, correct? I is 0. Please confirm 0 only. For J in the range of I plus 1, I think we need to take I only, right? If L of J, sir, please be on mute. Ravi is greater than max index will become J. L of max I say. What is the modification? Something logic is not working. Anyone, can you please cross check? What is the logic? Max index we are assigning to 0. Okay. Here we have to start from, yeah. Sir, here we should not compare from I plus 1, right? We have to compare from first location onwards. Because 0th location we consider. From first location onwards, we have to compare till end, right? And I think last index we are not required to consider. We can subtract with I. Now, sir, L of J is compared with max element, then max index will become this one. Now we are swapping the last element location. Let me try now. Can you please compare now? Sir, is sorting is working perfectly? Anyone tell me? Is sorting is working?
Yes.
Yeah.
Yes.
Next. Sir, same thing if you want to do for minimum element, what we need to do? Sir, here in the place of max index, take min index. Okay. So next we have to move that min index, means here you need to take less than. Except that remaining things are same. Sir, max index is not available. Where?
Line 8.
Clear, everyone?
Sir, one question on why we are assigning maximum I to J in program.
I do.
J, I is equal to J.
Where?
Line number 9, I'm getting confused there.
See, madam, we are taking the first element as the 1 second. I will show you in the diagrammatic map, then you can understand. Now, so listen carefully. These are the elements that I have in the list, correct? So now, minimum index. What is the minimum index value? Every time we are taking the element which is there at a 0th location is the minimum. So which element is there at 0th location? 40. I am considering the element of 40 is the minimum, right?
Right, yeah.
Now, j value is initially 1. When j is equal to 1, I am comparing L of j, L of 1, which is a 10. Is it less than the element available at min index, that is 40? Is the condition is true?
Yes, true.
If it is true, the element which is there at 0th location is not minimum, right?
Yeah, okay.
Now, which element, which index is minimum? 1. Correct? Huh?
1, correct. Yeah.
Now, that 1 we have to update here.
Okay.
You understood the
I
point?
understood. Yeah. Thank you.
Yeah, okay, madam. Sir, clear everyone? If you are clear, then I will go for the next sorting. Clear
Prakash,
everyone?
I have a quick question.
Please,
So
go ahead.
here the whole funda is about find the max and put it in the max index, right? So find the max
Yes.
element and put it in the max.
Yes,
So
sir.
why can't we just take the max function instead of writing greater than or less than all this? Take the whole index, find the max, put it in the max index, and just go remove the max. I mean, like now go to max minus 1 and just go for the range 0 to max minus 1. Check the max and put it in max minus 1, and we can recursive like that, right? Instead of checking greater than or less than, can we use
Yes,
function
we can
max
use,
and
but yeah, we can use. But my main intention is to explain how theoretical it is working, right?
yeah, got it. But I mean, like using the
We
functions,
can
I
use. There is no issue. We can use.
got it. Thanks.
Right.
Sir, can you drive one full iteration for I equal to 0? I equal to 0. Like
I
I
already
equal to,
written, right, madam? Already I've written.
okay.
Right. Can I go for next sorting? Right. Let us go for the next sorting what we have. Let me copy paste this for descending order. Already we executed, right? Now, so let's go for the next type of sorting algorithm here is insertion. Insertion sort. So what is mean by insertion sort? Sir, it is a simple sorting technique. It is a simple and easy sorting method like playing cards. Sir, in playing cards, what we are going to do? Suppose if you, in your hand, if you have some three cards, let us consider one and then three, okay, and then you have five like that. So on the desk, if you are getting any card, assume that the card number is 2. You will take this card 2 and you will insert that in a proper position, right? So I think you people are having this kind of habit also. So just taking a card from the deck and putting in its appropriate position. So indirectly, sir, it uses which sorting? Insertion sorting. In the playing cards, the mechanism which we are applying is insertion sort only. Clear? Clear. And so whenever we need to define in a technical term, assume the elements we have like 40, okay, next 30, next 20, so 50, and then 10, like that. We will divide this into two parts. One is a sorted list, another one is unsorted list. We will take one element from the unsorted list. We will move that element to the sorted list in a proper position. So 40 is moved. Now we have to move 30 also, right? So where it will come in front of 40, like that. So next, sir, I want to take 20. Where it will come? Sir, in front of 30. Now I want to take 50. Where it will come after 40. So taking the element from unsorted list, putting in a sorted list, so to meet our requirement. Okay. Sir, iteratively inserting each element, so of unsorted list into sorted list. Sir, clear? This line is clear for everyone? Yes, please confirm. Next one, it is a stable sorting. Stable sorting means what? If any duplicate elements are there, it won't change its relative order. And it is in place. It is in place sorting. No extra space is required. Okay. Sir, what is a real-time example for this? I already told playing cards is the real-time example. Okay. Sir, when we can use this is if the list is very small. Okay, then we can use this approach. Let us take direct example and I will show you. Can I go for a program? Please confirm. Clear, guys?
Yes, sir.
Right. So let us write code for this. Please be on mute. Insertion sort I am taking. Sir, DEF insertion sort I am taking, where it is taking a list. Sir, assume I am taking the length of the list. For I in the range of 1 to n, for I in the range of 1 to n, sir, I am going to select one item. Now, I will compare that item with the remaining items by using this loop. How this loop is going to work, I will demonstrate with code. Now, observe carefully. So we will take some elements here. Let us consider the elements are nothing but first I will take 40. Okay. So then I will take 10. Next I am taking 30. So next I will take 50 and then I will take 20. Please listen. I will explain all the iterations. This is 0th location, first location, second location, third location, and fourth location. For every iteration, I am demonstrating. If anywhere confusion is there, please ask there itself. What is the length of the list here? Please interact. What is the length of this list here?
5.
5. So I value is always starting from which location? 1. You can see here. We are not taking from 0 because I am dividing this list into two parts. This is a sorted list and this is unsorted list. Sorted list is having only one element means what? Already that element is sorted. Correct, sir?
Yes.
Okay. Okay.
Clear?
Clear. Yeah.
So now, so for I is equal to 1, now we have to do x is equal to L of I. L of 1 is how much? 10. Now J value is going to start from I minus 1, which is nothing but 0. Check this condition. Sir, is J value is greater than or equal to 0? Yes. X value, is it less than L of J? X value is a 10. Is it less than 10? Sir, condition is J value 0, right? 0th location element is 40. Sir, condition true, correct? 10 is less than 40, correct?
Correct. Correct.
Now what we are doing? Whatever element is there in L of 0, that we are moving to L of 1. In L of 0, 40 is there, that I am moving here. Clear, friends? Next, J is equal to J minus 1. Now J value will become 0 minus 1 means minus 1. Is next time, is J value is greater than or equal to 0? No, condition is false. Now coming out from this loop, and there is one last code. What is it? L of J plus 1. J value is minus 1. Minus 1 plus 1 means 0. L of 0 will become X. What is X value? 10. Now this value we are allocating. Now divide the list into two parts. This is a sorted list and this one is unsorted list. Clear, friends?
So in the while loop, we are just comparing the first two elements, right?
Yes.
Not we are going beyond that.
Next time, 3 elements. Next time, 4 elements. Like that.
Okay. In the first while, we are just comparing the first index 0 and index 1.
Yes.
Okay.
Now, tell me what is the next time I value?
Next time I value
2.
will be 2. Yeah.
What
So
X
30.
value? 30.
30.
Now, what about J value? I minus 1. I value is 2. 2 minus 1 means 1. First condition while loop is J value is greater than 0. Yes. X value is 30, right? Is 30 is less than L of 1. Sir, condition true or false? Please confirm. True. True means what? L of J plus 1. That means L of 2 will become L of J. That is 40. So 40 we have to update here. Next, J minus minus, J value will become 0. Is 0 greater than or equal to 0? Yes. And X value is 30. Is 30 is less than L of 0? 10. Condition is false, right? Correct? So whenever smaller element is going to come, it will stop. Whenever bigger element is there, it will continue. Got it, friends?
Got it.
Now what will happen? So this while loop is failed. Now L of J plus 1. J value is 0, right? 0 plus 1 means 1. Which element will be copied? 30. Can I say now the list is divided into two parts? Sir, sorted list, unsorted list. Clear?
Clear.
Now, let me try for the next iteration also. What is the next iteration? Your I value will become what? 3. Sir, for I is equal to 3, your X value will become L of 3, which is nothing but 15. Your J value will become 3 minus 1, 2. Sir, is J value is greater than or equal to 0? Yes. Is X value is less when compared with L of 2? No. Come out from this. Sir, L of 2 plus 1, 3 will become 50 only. The same element will be updated. Now this is divided into like this. Clear, friends? How insertion sort is working. Clear? So let us execute and check really is the sorting is happening or not. Can you please cross check? Is the sorting is happening? Please confirm.
Yes, it is.
So how you can do for descending order? Can I take here greater than symbol? Clear? Any questions? Any questions? That's all. This is nothing but how insertion sort is going to work. So with this, I'm going to wind up the demo sessions. So from next week, we will be having the regular class. Next week, Saturday, we are going to see merge sort and quick sort. So if possible, one more sorting I will add. Then various searching algorithms what we have, and the introduction to time and space complexities also I will cover in the next week. Okay.
Sir, this short and shorted method follow which mechanism then
There is one
internally?
special sorting is there called tim sort. Tim sort. It is going to follow that.
Okay, both the method and function, na?
Yes, yes,
Short.
exactly.
Okay, sir.
Sir, yesterday's class we need the notes in video because I could not understand many things.
Yeah, sure, sure. We will share.
We missed it actually. See,
Yeah,
that
yeah.
was
So
crucial,
how we
sir.
can
So
access
many
this data?
Sir, one by one, please.
Yeah, how we can access these notes, programs, and videos
These notes and all we will share from the next week, sir.
next week? Okay. So it will be individual portal or in this chat only, like from where we can
No,
access?
we are going to give a drive link.
Drive link. Okay. Got it.
Yeah, I
So
will share that video, sir.
we'll get the demo videos, right? We'll link for
Yeah. Demo videos also we will share.
yesterday's class
Yeah, I will share. I will share.
crucial, I suppose, because I missed everything.
Yeah, nothing. It is very simple only. I will share. Don't worry.
The
Okay.
class timings will be same, sir, right? Starting
Yeah,
from 6
sir.
p.m. to.
Class timings are same, not 7 p.m. Yesterday, I have given the confirmation to our team also. So the class timings are from 6 p.m. only, not 7. We will start at 6 p.m. Okay.
so
Yesterday I told it
6.
is 7 p.m. right? So I informed to my students also, my previous batch students. So they are okay for that. So the session timings are from 6 p.m. We will
Okay, sir.
start at 6 p.m. We will wind up by 9 or 9:30 like that. Okay.
Okay, I have a quick question. So until now, like all these sorts are in place sorts, right? So, I mean, like, so
Only
all these
only merge
conversion.
sort is not in place, except that all the sortings are in place only.
So I mean, like in this process, like it's not creating any more byte space to do the comparison. That's the reason
Yes,
it's
yes,
not
sir.
using it. Okay,
Yes, sir. Yes, sir.
thanks.
Yeah.
Sir, for
Any
next
other?
class, where we'll get a class mail link? It's on email or?
We will share through email only, madam.
Okay.
And sir, one last question. Like, if we have to, in our algorithm, let's say we defined our own algorithms for some logic, and we have to calculate the time and space
I will
complexity.
demonstrate. I will demonstrate in the next
Yeah, that
session. You
how
will
we
get.
can. Yeah.
Any other? Okay, right, guys. See you then. See you in the next week.
Thank you.
Thank you.